AI can dream, but metal doesn't care.
Today we're taking Witcher pendants from AI image to Blender cleanup and 3D print, and finally real metal finishing.
If it can't be cast at 1000 degrees Celsius, it doesn't count.
Our constraints: it needs to be printable, castable and wearable.
There are many ways this fails. The generated mesh could be full of holes, dimensions could be completely wrong, material thickness could not be suitable for metal casting, it could be too heavy, and so on and so forth.
In this video, together with Gesa, expert goldsmith, we're gonna let her cook, or should I say cast. Alright, let's start preparing 3D model. So here's the reference that we took as a starting point. It is a pendant from the Witcher series, really good one, especially first seasons with Henry Cavill. Ooh, my favorite one. So from that image, I created two reference images like this. Of course, I used Nana Banana. We're gonna skip that part, but let me know in the comment if you have problems with it and I will consider a video about it. And here's the thing why multi-view actually matters here, since we need to explain what will be on the backside. For metal casting, the inside part can be hollow, but we're gonna approach it in another way. And also it is important to show that this one is not tilted and how far the nose, like what is the overall extrusion. Of course, I could remove this loop and piece of chain, but guess I will show you how to clean it up in next steps. And for 3D generation, we're gonna use Item 3D, which in my opinion is really good for hard surfaces and detailed stuff. You can see some amazing examples here, how many details and how accurate they are. Well, let's give it a try. I'm gonna choose the multi-view for this one and let's upload my references. Okay, so there will be this and this. And by the way, they added like quite a lot of stuff like 3D relief. I'm gonna go with the latest model, but 1.5 sometimes give really cool results. And I'm gonna go with 1536p Pro resolution, which is, as you can see, also print ready. This is exactly what we need. I'm gonna create it with texture, but we don't really care about texture, just to take a look on the results. And I'm gonna go press generate. All right, here we go with the results. And it actually looks cool. It even feel a bit sort of metallic. But we are not here for this, right? We are gonna need to cast it. So let's review the geometry. So the details here completely unneeded. And of course, we're gonna need to remove this. Also, we can see some very thin details here and here, not really ready for printing. I guess I will spot even more problems here.
There's lots that can go wrong with AI and 3D generation. This model in Item 3D was okay, but didn't have good geometry overall, especially the backside. With 2-image multi-view, the backside was good, but the frontal geometry was unacceptable. So it can take some iterations and multiple tries. With the second multi-view, I used 3 reference images and the result was really decent, but I didn't really have control over the material thickness of the hollowed out version. So in the end, I opted for hollowing out manually in Blender, and I actually combined 2 3D AI generations to get the final result.
If you're not happy with generation, you have up to 3 retries, which I'm gonna use right now. My goal is to figure out the best and send it to Gesa to process. Okay, so here is one more generation. Here we can see these are a little bit different. I think I like the previous one more. Okay, so here you can see you will need to fix them quite a lot. But the backside here is flat, which is exactly how it looks on the prompt image. Here is one more example. The teeth here are smaller and we do have like some teeth here, which is a bit strange, and some strange piece here. Oh, we're definitely skipping this one. Okay, so we're gonna stick with this one. I'm gonna export it and Gesa will take over from here.
I drag and drop the Item 3D STL into Blender. The goal, make it printable, castable and wearable. First problem is the bail. If we cast it like that, it will be stiff and hard to clean. So I cut it off completely in sculpt mode by using the box cutter tool. With Printable on, smooth the area out to get a clean slate. Next, the lower teeth were way too thin. Prints get fragile and in casting finishing, those tips can just disappear. I fixed this by selecting a small face set, extracted it, and used the resulting new mesh as a base. Then I turned on Dintopo and used the snake hook to sculpt new gums for the wolf. Now the teeth have backing, they survive printing and they won't get polished into nothing. Then I upscale the model. The smallest features need a minimum size, like 0.3 to 0.5 mm in minimum for engravings. Also make cavities as deep as they are wide. Result, details work outside the virtual world. Next is a biggie. thickness and surface. Metal finishing eats up micro detail, so I'm constantly checking, is this thick enough and bold enough to survive printing and finishing? Actually, the AI did a decent job here. Especially the eye recesses and hair spikes already look pretty great. I strengthened some main details like the brow line slightly. I moved the indented ears outwards, just a little bit for thickness. I also did some small aesthetic tweaks like notching the chin. End result, a design that looks sharp from all angles and no hidden material weaknesses that suddenly produce unwanted holes during polishing. Next issue is weight. If we cast this in solid silver, it gets heavy fast. So we hollow it. I cut the back flat to create a plane. Then I extrude that back a bit, so there's a little bit of extra shell thickness. After that, I use the 3D Print Toolbox add-on to create a hollowing object. And I cut the back open once again, so the inside becomes hollow but is still watertight. So we get a much lighter piece, still printable, still castable, and no hidden internal geometry. Finally, I fill some of the deeper cavities. Undercuts are generally no problem in digital, but in casting they can create problems. They can trap investment and make cleanup miserable. So I filled it with some blender goo, which is just a simple mesh. Fill the cavities, Boolean union. Result, smoother casting, less cleanup, and less heartache in general. Finally, I add a simple bail. A single Bezier circle with round bevel depth. Easy to test with a leather card. I did a quick mock-up on a chain, and then it's off to the slicer for PLA printing. Result, AI rendered, transformed into a manufacturing-ready model. For the FDM test print, I used Prusa Slicer with my Prusa MK4S printer. After cleaning up the supports, I attached a nylon thread to my pendant. This helps to check the tilt and proportions and to spot potential problems before committing to metal. After the FDM, we did a resin test to really check out the small details. Here's the resin check version. The quick process is printing, washing in IPA, curing, supports off, and final touches. Now, the important part, the details survived. Teeth, edges, and the silhouette all read really well in real life. So the geometry is solid, even with a high-resolution print.
It was actually very easy to print, and we didn't spend too much resin in it, like quite small piece. Did it really fast. I think the size is almost perfect. Like this is exactly the size I was imagining it. I think it's important that it's hollow because it also will be not that heavy. Because I imagine like when it will be in metal, it will be quite heavy potentially. And yeah, you can see how it sits on me. I think it looks really good, like perfect size. This is exactly how I expect Pendant to look like. Back to Gesa.
The test prints worked, but the model didn't yet feel premium. I didn't fancy the look of the hollowed backside. It felt bulgy and not as sharp as the front. So I actually combined the two AI versions to get a really sharp-looking hollow with proper wall thickness. It gives the weight and finish of a real product without making it too chunky. Also, it gave me maximum control over material thickness. I aim for around 1.2 millimeters. The problem, I have one model with nice frontal geometry and one model with nice hollowed-out backside. How to combine these two in a way that doesn't make my head or my computer explode. To solve the computer problem, I decimated the second model's vertex count for easier handling. To combine the models, it's helpful if both have a flat outline on one side. Hence, I cut off the back just like I did with the first model. Currently, the hollow was still attached to the whole second pendant, so we needed to separate the geometry of the hollow from the rest. In edit mode, I deleted the flattened faces and separated the hollow into its own object with P and selection. To make the pendant ready for accepting the new hollow part, I needed to do the reverse on that one to get rid of the old hollow part. Now I had two open meshes and needed to prep them for booling. Then the next problem, the two parts didn't really fit together. The hollow was poking through the front. It was necessary to adjust and sculpt on the hollow part to make it really fit. To avoid deforming the edge too much in this process, I box masked it prior to sculpting, and that worked surprisingly well. The hollow needs to be a solid so that we can cut it from the main piece. For this, I extrude a little bit from it so that it reliably cuts open the pendant. Working with such detailed models always slows down the process a little bit. To prevent long calculation times, I remesh the hollow part. Now we can't yet bool the hollow from the main piece, as the main piece is still cut open. So I created a similar extrusion. This also gives maximum flexibility in terms of material thickness and object depth size. I used a jewel craft add-on to measure the weight of the current state. Right now it weighs around 15 grams in sterling silver, which is one of the most common silver jewelry alloys. I gave it some finer tweaks to prevent any super thin parts. And to finalize, I built the hollow from the pendant and cut off the excess extrusion with a simple cube. And as a finishing touch, a new bail was created to complement the spiky style of the wolf's head. This type of bail is super straightforward and it doesn't need soldering. And now that the inside is properly engineered, we can send it to the end boss, casting. So resin is our high quality sketch, but metal is the final boss. Not every resin is castable. If you want to use resin prints for investment casting, you need special castable burnout resin that burns out clean, otherwise you can get residue, ash in the mold, and that can ruin your surface quality. First, the lattice supports get dissolved in IPA, which is satisfying but also slightly terrifying. Then, we add wax sprues. These are the highways for metal and the escape routes for air. Everything goes onto a big wax tree. And this is a placeholder because client privacy is a thing. Next, we do investment plaster. Gypsum gets mixed, then we vacuum it so that bubbles don't sabotage the details. And then we pour the molds directly in the vacuum chamber and get all the air out so that we have a very, very dense gypsum. So the cuvettes need to be in the oven and get really hot to burn the resin out. And then to melt the silver, we take some granules and fill them into the hot cuvette. They melt pretty quickly and get ready for casting. After burnout, the wax is gone and the mold goes into the casting machine. Through that little window, you can see molten silver ready to pour. See how it cooks in there. Then we use giant tongs to get out the mold. And finally, once the tree is out of the gypsum, we sandblast the whole thing. And the print finally levels up into metal. Alright, the casting is finally done. Let's move on to the bench for the finishing steps. And then we will see if we actually get a finished piece of jewelry from a 3D AI-generated piece. Thanks to Horbach Technik GmbH for the wax prints. And a huge thanks to Herterich GmbH and Co. KG and the owner Roger Chermak for the silver and brass casting and filming the casting magic. This is the finished pendant. It looks expensive now, but it started as a raw cast. And the raw already looks pretty cool, but cool isn't the same as finished. The last 10% is what makes it wearable and into a real piece of jewelry. So let's watch it transform at the bench. First problem. We have the casting sprue at the back, still attached. So we need to saw that off. This is basically the cast umbilical cord where it was attached to the casting tree. Once we've sawn that off, we need to file it until the surface is relatively flush, because then we need to sand it flat. And in these stages, I have to be really careful to not saw into the surface or file into the surface at the back, because that would leave very deep scratches. After the back is flat, I can then proceed to clean off the casting skin from the front. I do this by filing it, then sanding it, and also going into all these curved surfaces with a Dremel and a diamond burr. Once that's done, I go over the surface with rubber wheel to buff it up. This already gives it a kind of shiny look. See the difference between the filed surface and the casting skin? You immediately see it that the filed surface is much shinier. And once I removed all of the casting skin basically and sanded it finer and finer, I go over the whole piece with a small polishing wheel. And I have to be really careful here because I could accidentally flatten all the nice edges and round off all the shapes. Polishing eats shapes quickly. So that is the in-between result. And you can see it doesn't really read clearly on camera yet, because it's now even less pronounced than the raw brass cast. But we'll do something about that in the next steps, which is oxidization and the final polish. And now, oxidization. I love that part. It looks so cool when you put the oxidizer onto the silver surface to permanently blacken it. Look at that. Isn't that super satisfying? So once in a while, we should go the extra mile. So this is how it looks after all of these steps. And I think what really paid off here is that I reworked the backside prior to casting. I just love how the detail on the backside matches the front. I think it looks really premium. So here's the final result once more. Someone is really looking fancy here. Let's compare the raw cast once more with a finished piece. What do you think, guys? Was it worth it? Do you think Gerald would like to wear this? Or Siri, maybe?
Okay, so this is the whole pipeline. We started with an image, created a 3D model, and prepared it in Blender. Then we printed it in resin, and when that's done, we casted that in metal and bench finish in real silver.
Biggest win, obviously, it's actually possible to create real jewelry with an AI-generated 3D model as the starting point.
The biggest risk, AI-generated models are usually not enough to be printed right away.
Although they already have pretty high quality, but they still need careful cleanup and prepping for 3D printing and casting, keeping the real-world constraints and material weight in mind.
Now you know the best and fastest way how to turn your AI object into a model that is ready for printing and metal casting. We have put a PDF, the link in the description, to give you an overview of most important points you need to take care before jumping into real manufacturing.
So, what should we do next? Comment the next piece and tell us which material.
Whether that will be brass, silver, or should we go for gold? I hope you enjoyed the video and it was extremely useful for you. Don't forget to like and subscribe, and see you in the next one.
Hope you enjoyed and see you in the next one.